Hello and welcome to the Walking Talking Topic Multi-Mark Week 5 set of questions, and this is question number 2. Right, we've got Eliza here. She makes a sketch of a pond. The shortest distance across the pond is 6 metres and the longest distance across the pond is 20. So I'm going to mark on here that there is 6, and across the pond, all the way across, we're going to have 20. Okay, Eliza estimates that the surface area of the pond is 120. Explain why the surface area of the pond is actually less than Eliza's estimate. Well, that's quite nice actually, because if you were to just draw yourself around Eliza's pond here, a nice little rectangle, and just do a bit of this. Oh man, sorry, that's terrible. Bit of that. And a bit of that. So if you draw yourself a rectangle just around Eliza's pond there, the area of the rectangle, what would that be? Well, the area of the rectangle, that's just going to be base, which is 20, times by height, which is 6. That's going to be 120 metres squared. But we can see that the rectangle misses bits out. So the rectangle has parts of the area included that are not included inside the pond itself. So I'm going to just write that area of a rectangle equals 120 metres squared, but I'm going to put rectangle covers more area than the pond. And because I've written that down, and because I've shown it on my diagram, and maybe I'll put a little arrow there just to show them, I think that's enough to get me the mark there. Perfect. Now let's move on to the big money bit of it. 6 marks. Calculate an estimate for the surface area that will be more accurate. Show all your work in and explain how you've decided to calculate your estimate. Well, this is quite tricky, but we are going to get 6 marks for it, so fair enough. Right, let's go back to our original shape up here. What have we got? Well, if we divide it up like this, and again, get me a very fashionable ruler out here, what you'll see is we've essentially got a rectangle there, and we can probably make a fair assumption that these are kind of like semicircles, each of these 2 bits on the end there. You can perhaps see it a bit clearer on this one. So if we can work out the area of this rectangle and also work out the area of those semicircles and add them on, that's going to be a better estimate than just assuming the whole big thing's a rectangle. But how on earth are we going to do that? Well, it's actually not the worst thing you've ever seen in your life, as long as you remember something very, very, very important about semicircles and circles. And to illustrate this, I'm just going to dot this point round a little bit to see the circle. So I've got a circle there. But do I know any measurements on this circle? Well, I do actually, because I know what this distance is here, right up here. It's got to be 6, because the height of this, the pond, or the distance across the pond, is 6. So that is a circle. And in fact, if I just recreate this circle down here, just so it's a bit clearer, I've got myself a circle, and I've got a diameter of my circle is 6. Okay. So what's my radius of my circle? Well, if my diameter of my circle is 6, my radius of my circle is just going to be 3. And the reason the radius is important is because that's how I work out the area of a circle. So if I want the area of a circle, what's my formula for area of a circle? Well, it's going to be pi times my radius squared, pi r squared. So I can work out the area of that entire circle. And once I've got the area of that entire circle, if I just want this bit of it, all I've got to do is halve it. Dead easy. So my area of my circle is pi times my radius squared. Well, my radius in this case is 3, so pi times 3 squared. I think 3 squared is just going to be 9, so it's going to be 9 pi. Now, the nice bit here is I can work that out on a calculator, but I like to avoid decimals where possible. So now I'm going to put area of semicircle, because I don't want the full circle. All I'm interested in is this bit of the circle. Well, if my area of my full circle is 9 pi, my area of my semicircle has just got to be half of that, 4.5 pi. And what I'm going to do, just to make this clearer, I'm going to label that as kind of area 1. This is area 2, and this is area 3. So area 1, I reckon, is 4.5 pi. What about area 2? Well, that's nice, because area 2 is just a semicircle as well. And it's the exact same semicircle as this, with a radius of 3. So again, the area of that has got to be 4.5 pi as well, which is quite nice. So now all we're left with is area 3, which is the rectangle in the centre. So again, I'll just do a little sketch of this rectangle just so we can see it a bit clearer than in my diagram. And let's have a think. What have we got to deal with here? Well, we've got a height of 6, that's fine. But what's our width now? It's no longer 20, because we're not going right up to the edge. We're going to the edge of each semicircle. So that kind of bit that's missing off the end here is just the radius of that semicircle. That's what's missing, that little bit there. And we said the radius of the semicircle before was 3. So it's got a 3 missing off the edge. It's also got a 3 missing off the other edge there with the radius of that semicircle. So we're missing 3 and 3 either side, but we know our entire width has got to be 20. Well, we're missing a 3 and a 3, which is a 6, so I think that bit there has just got to be 14 metres. So my area of my rectangle is just going to be 14 lots of 6s. Well, I'm going to need a calculator for doing my pi, so I might as well save myself a bit of brain power and do 14 6s is 84 metres squared. So now I'm laughing because I've got my first area is 4.5 pi. My area of my second bit is 4.5 pi. And my area of my third bit is 84. Now all I need to do to get my total area is add them together. So total area. And this is where I'm going to reach my calculator. Now the only thing that can go wrong here is if you can't enter pi's into your calculator, but I think we'll be fine. 4.5 lots of pi, I press shift and I'll just show you just on the camera, and it's that button there, 4.5 pi, plus another 4.5 pi, plus my 84, press equals, and the calculator will give it me nicely as 112.274 ... centimetre, oh not centimetre, sorry, metres squared. Check it hasn't asked me to round it to anything, it hasn't. I might choose, seeing as it's an estimate, I might say that that's about 112 metres squared. Now I'll tell you what's nice about this, and I'll put to the nearest hole there, nearest hole. To get a rough idea of whether you're right or not, we said before 120 would be an overestimate. So 112 is less than that, but it's also close enough. Like if I got like 15 or something, I'd be worried. And if I got more than 120, I'd definitely be worried. But I'm thinking that's about right, that. So I'm very happy with my answer there.